Hello everyone, very warm welcome to all of you on the platform of KSG India. My name is Akhilesh. Today I am going to discuss about the neutron star, how it is going to be formed, why they are called as pulsating star or pulsar, and what is the significance, and can we assess this kind of neutron star approaching towards Earth? What is the reason, or what are the characteristic of these neutron star through which we can perceive, yes, indeed we are under the attack of this neutron star. Don't have you ever thought about this neutron star? If approaching towards Earth, what would be the fate of Earth? I'm just giving you the concept to ponder about. Read it. Any neutron star, if approaching towards Earth, it is not good at all. So please read it from internet. There are many interesting fact related with this neutron star. So as I have discussed about Chandrasekhar limit, this Chandrasekhar limit is what the it depends upon the size of the star. If the star is going to be massive, it has different stages of the life. If it is going to be smaller, it is going to have different stage of life. What is it? It is 1.44 solar mass. This is what called as Chandrasekhar limit, for which Subramaniam Chandrasekhar was rewarded Nobel Prize of Physics in 1983. So let me explain this neutron star. Fine. So when the star is going to be massive star after supernova stage, it will form neutron star. Fine. Basically, this neutron star is the core of the massive star. It is nothing but the core of the massive star. Why it is called as neutron star? Let me explain it. This core of the massive star is going to be massive as compared to the smaller star, indeed, and because of the superincumbent gravity, the core of this massive star start crunching under own gravity. This is the core, and due to the gravity, this core start crunching. This is the core of massive star. So let me explain it with a hypothetical image I'm going to make over here to make you understand what exactly this neutron star is. This is 4 atoms at a time. These are the 4 atoms. It has a nucleus. I have just taken this 4 atom just to make you understand the concept of neutron star. This is the 4 atom. And atom as well as nuclei, if you have the basic concept of atom and nuclei is going to be very tiny, almost 10 to the power 6 times smaller than the atom. 10 to the power 6 times, 5 times smaller than the atom. Means अगर मैं इस पिक्चर को बना के कहूँ कि ये मैंने एटम बनाया है, तो it is not going to be justified unit. Means in a huge room, आप ऐसे कंसीडर कर सकते हो, शायद वो भी सही नहीं है कि आप एक मल्टीप्लेक्स में बैठे हो और आपके सिर का बाल और उस बाल का पॉइंट as comparing to that multiplex room is going to be a atom with respect to that this nucleus. So nucleus is very tiny as compared to the atom. Fine. So these are 4 atoms. It has a certain volume V. Okay. And this 4 atom is going to have proton and neutron, which is present in the nucleus, and electrons are revolving inside the orbits. These are the electrons, and you all have this nucleus is going to have positive charge. The same number of proton is equal to same number of electron. This is what the atom says. Atom में क्या होता है बच्चे? Atom के nucleus में number of proton is equal to number of electron. अगर बाहर 2 electron हैं, इसका मतलब nucleus के अंदर there will be 2 protons. Fine. So 2 protons and 2 neutrons. So their number is going to be same. So if there is negative charge, there will be net positive charge on the nucleus, and both the charge is going to be maintained over here. And net charge on atom is going to be 0. What happen when the gravity start crushing these atom? तो gravity कहती है और जगह है, क्रश हो जाओ. एटम कहता है कहाँ जगह है. हाँ बिल्कुल वैसी ही लड़ाई होती है जो वो शॉर्ट वीडियो में है ना. When gravity start crushing it, atom means resist to be crushed, but the gravity is super incumbent, and the gravity is knowing that still the core is in its atomic stage. Still there is huge space left. If I crush them, that space is going to be breached. So what happened? This gravity start pushing it, crushing this, because why this super incumbent gravity? Because this is the core of massive star. So what happened? The atom crushed into the nuclei. The electron start absorbing inside the nuclei. So what happened? Let me give you idea. This is what? 2 protons. These are the protons. And there are 2 neutrons. So neutrons are neutral. Protons are going to have positive charge. And it has this shell, that is what? The outermost orbit, in which you are going to have electrons, very tiny electrons. These tiny electrons are having negative charge, and when gravity start pushing it, so still this space is going to be huge. Space around the nucleus, चारों तरफ ये space होता है बच्चे. When it is going to be pushed, this electron get absorbed inside the nuclei. The electron get absorbed. As the electron get absorbed, what happen? This positive charge get neutralized by this electron. Fine. The positive of proton is going to be neutralized. Now this is also containing same negative charge. No charge. That is what? 0. Just like the neutrons. So proton having positive charge, then only it is proton. And proton having no charge is not other than neutron. So this proton is going to be converted into neutron. So inside the nucleus, we are going to have only neutrons. Only neutrons. Why only neutrons? Because the proton which was having positive charge, its charge was neutralized by the absorption of electron. Why this electron is going to be absorbed by the nucleus? Because of the superincumbent gravity. Why this superincumbent gravity? Because this is not the core of ordinary star, it is a core of massive star. So there is superincumbent gravity. So what happened? Try to see over here. The atom turned into nuclei. Let me tell you the changes. These are the 4 atoms, and it has turned into 4 smaller nuclei. And the nuclei are going to have there. Tell me, is there change in volume? Massive change in volume. Are you getting my point? Tell me, the mass was m earlier, and the mass is what? Proton plus neutron, and electron को negligible मानते हैं, फिर भी जोड़ लो electron भी. So this is what the total mass of the atom. Tell me, is there change in the mass? Answer is no change in the mass. Why? Proton, neutron and electron all are going to be here. What is going to be bridged? The space within the atoms. So what will happen to the density? Density is what? Distribution of mass per unit volume. Density, if volume is going to be drastically reduced, density is going to be drastically increased. So size of the core is drastically reduced. But what about the density? Density is going to be drastically increased. So the size is smaller. That means the neutron star is going to be smaller in size than as you compare the core. In case of white dwarf and black dwarf, they are almost having similar size. But what happened to the neutron star? They are reduced in a very small size because they all are made up of neutrons only. Why they are made up of neutron? Because the proton, which was having positive charge, is going to be neutralized by absorption of electron inside the nucleus. Proton without charge is nothing but neutron. That's why the name neutron star has been given. Neutron star. Fine. And this neutron star is also called as pulsating star. It is called as pulsar or pulsating star. Why it is called as pulsating star? Because it radiates residual heat. Do remember, there is no heat produced, no energy is going to be produced. It is the residual heat which is present in the core is radiated in form of radio waves, radio pulses. So this neutron star is producing certain amount of radio pulses, release radio energy in form of radio waves, and that is not a continuous release. This release in form of pulses also. Today it has released some pulse of radio wave, some amount of energy, and then it will subside for 100 years, next 100 years. Then one day इसका मन किया फिर release energy कर दिया. So they release energy. This neutron star or pulsar is going to release energy in form of radio waves, and that too in form of pulses. That's why this is called as pulsating star or pulsar. Again there is a question, कि is it visible? Can we see it easily? Answer is no. आज उसने रेडियो वेव्स रिलीज की, अब आप टेलीस्कोप लेके बैठ गए, अब वो अगले 100 साल के बाद 75 ईयर्स के बाद या 150 ईयर्स के बाद रेडियो वेव्स निकालेंगे, तो आप कब उसको ध्यान दोगे? पता चला जो देख रहा था वही निकल गया. Is it okay? So it is highly elusive. We are not able to see them every time, but yes, we can feel them. Feel them by their strong gravitational waves. And again, this gravitational wave as well as LIGO experiment. LIGO is what? Laboratory, which is established even in India to observe this strong gravitational wave of celestial body in order to save our Earth. Although if such kind of body is approaching towards Earth, we don't have any other option rather chanting Hanuman Chalisa or praying to God, क्योंकि उसको रोक पाना हमारे बस की बात है नहीं. लेकिन हाँ, ये पता चलने से ये बात समझ में आ जाती है कि कितना समय हमारे पास है. That's why this gravitational wave observatories are established worldwide, and this is equally important for your science and technology topic. So please go and see this LIGO observatories, how it is going to work. And this strong gravitational wave received on the Earth is telling about the story of such kind of massive gravity around the Earth. How much near these gravity are there can only be assessed on the basis of the intensity of this gravitational wave received by the LIGO observatories. So this is all about the neutron star, and this neutron star is going to have massive high density in a very tiny volume because they all are made up of neutrons. I hope I made my point clear to you. Thank you very much.